In this video, we're going to continue to look at enclosing our Keystone Library structure by adding roof elements into the model. With this, we're going to go through and be looking at the second level roof, or the upper roof is what it's commonly called, and we're going to look at the framing that's in place. We have some K-series open web steel joists that are going to provide for the structure, and then we're going to show two methods. One will be a roof by footprint, and the other one will be a roof by extrusion. So in this video, we'll take a look at roof by footprint with if we want to create a regular low slope roof on the top level of our building. So I'm going to go ahead and move to the upper roof framing as our level. Here, the one thing to notice is that we are set at 5 foot span between our joists. So that's going to go through and kind of help dictate some of the choices that we'll make design-wise within our model. I'm going to go ahead and go to roof, and I'm going to choose, with the drop-down arrow, choose roof by footprint. So like what we've used previously. Looking at the types that we have available, we really want the steel truss insulation on metal deck. However, this has already got the steel truss in it, so I will edit the type and I'm going to duplicate, and in this case, instead of going through and adding a second roof type of the same name, I'm going to go ahead and take out, and I'm just going to have it be insulation on metal deck. We've already got the structural steel elements there. The trusses are already in place, so we don't need to add a second layer of trusses in there. So I'm going to go ahead and edit this structure. We do not need the steel bar joist layer. We do need to keep the metal decking. Otherwise, if we don't have a structure, the roof will not work. Now, the metal deck in this case is 1/4 of an inch. Now, I've looked up, and there are always tables and information online. So for a spacing of 5 feet, 1/4 inch thick steel decking is not really going to work very well. So that corrugated metal that goes on. So what we're looking at is about 1.5 inches. So if I type in 1.5, or I could go through and even put in, I probably need to take out the 0 there, 1.5, and there we go. It converts over to 1.5 inches. So that's the steel decking thickness that is required when you have a span. If you have a greater span, then you would need to increase the thickness of that steel decking. If you have a shorter span, you can probably decrease that to something a little bit thinner. Here you have rigid insulation, and you have the membrane that is put on the top, 1/4 inch roofing EPDM membrane. So I'm going to go ahead and say OK. And say OK. And from here, I have on my options, I'm doing pick walls, so I can go ahead and just pick the walls for the roof. Looking at the location lines, they are going to the inside of the wall, which is what we want. And I'll go ahead and choose. Now we're on the roof framing in this case. One thing that I want to hit the green check mark is when I go back to the 3D model, I do want to double check to make sure that in this scenario, let me go ahead and hide my south wall here. I want to make sure that that roof is actually sitting on top of the joists and on top of the framing, and not going to be inside of the joist, which you can see right here from our joist. We do have the top part of our joist that is going to go through and to make that happen. So that's the only thing that we kind of want to go through and look at bumping this up by. So the top level of our, if I go ahead and hide my roof at this point, so you're going to end up getting, we're going to need a measurement to offset our roof by. So when I zoom in here, I can go through and kind of take a look at what kind of measurement that I have. Now I'm in the 3D view, which doesn't allow me to go through and to use the measure tool, but what I can do is utilize either one of the elevation views. So if I move to the south elevation, hide the wall in this view, hide the roof in this view, like I did in the 3D view, now I can see how far I need to offset that up by, which actually, if you look, we also have a line that pops up there to show you that there is the upper level, which is part of our grid system. So for our roof for our, there's the roof framing, and then there's the top part. So let's go ahead and let's look at the measurement that I need to offset by. I'm going to grab this lower left corner and the top corner. Looks like the measurement's going to be about 2.5 inches that I need to bump up the roof by. So I'm going to go ahead and in this scenario, I'm going to go ahead and look at, I'm going to need to probably go through and unhide this wall. And then as I turn off the visibility for that, let me go back to my 3D view. And I'll probably have to turn this at a little bit of an angle to be able to show the roof that's hidden. So let me go ahead and unhide the roof, and I'll toggle this back off, leaving the point there. Let me go ahead and select the roof base from base offset. So we'll do 2.5 inches and we'll hit apply. Now when we go through and we take a look at our joists, now you're going to see the roof sits right on top of the joist, which is what we want. We don't want it to be embedded into the joist. We could have gone through and created another level in there as well if we wanted to, but it's real easy just to go through and just offset that by going through and finding that measurement. So now we have our flat roof installed. I can go ahead and bring back my wall that I hid in one of the previous steps. And now I have a flat roof, or low slope roof is the more correct term, to go through and enclose the top part of my building. In the next video, I'm going to explore how to create a little bit more creative looking upper roof utilizing something called roof by extrusion, and then we will move on to the green roof in a